Okay, so we are going to look at some review problems for our Chapter 1 test in algebra. So we're just going to hit some of the main concepts that we've gone over in this chapter. So hopefully this will be a good way for you to review. And you can try additional problems. It's not like this is the only thing you can do for review. But if you're at home and you're trying one on the practice test or something like that, this is a place that you can review. But you're still going to be held accountable for these notes, so make sure and take good notes. Okay, so the first thing we were going to look at is how to order a list of numbers here. And first of all, I look at this. I'm going to separate the positives from the negative. So here I have two negative numbers over here on the left side. So negative 7/4 as a mixed number is negative 1 3/4. So I know then that negative 2 is smaller. So we start with negative 2, and then we do negative 7/4. All the other numbers are positive, so they're going to come after that. If I look at the different numbers, so pi is 3.14, then I have 6.5. Square root of 30, well, even without a calculator, I know that the square root of 25 is 5. The square root of 36 is 6, and that's in between there, so it's going to be 5 point something. And then I have 1/3, and 1/3 is less than 1 whole. So the smallest of those is 1/3. And then we would have the pi, because it's about 3.14. And then we would have the square root of 30, because that's going to be 5.5 or 6. And then the largest one is going to be 6.5. So that's how we list them. It says, then circle any numbers that are irrational. So irrational are numbers that cannot be expressed as a fraction. Well, negative 2 can be made into a fraction by putting a 1 underneath it. So that's rational. Negative 7/4 is already a fraction. 1/3 is already a fraction. Pi is a decimal that never ends and never repeats. So it cannot be made into a fraction. The square root of 30 is not a whole number, so there again we're going to get a decimal that never ends, never repeats, so it is irrational. 6.5 is 6.5, and if I make 6.5 into a fraction, we'd get 12 halves in 6 plus 1 more in the half. So that would be 13 halves. So there it is as a fraction. So that's rational. So our only two irrational numbers are pi and the square root of 30. We also looked at simplifying expressions and also evaluating them. So evaluating, we just have the order of operations. If I look at this first one, I would have to do the power first. So 2 times 2 times 2 is 8. And then I want to do inside the parentheses. So 9 minus 7 is 2. The next order then, I look left to right and do multiplication and division. So I hop over this plus 8. I don't do that. I have to do this first. 8 divided by 2 is 4. So then 8 minus 4 is 4. So to evaluate an expression is to come up with a number that's equivalent to it. Okay, simplifying, the next one. So to simplify, we would distribute first of all. So let's distribute the 5. So 10b plus 15 plus, then we've got to distribute the 8. So it'd be 8b minus 48. Our like terms, well, 10b and 8b are like terms. So when I add them together, I get 18b. And then we can always just add two numbers together, and 15 minus 48 is negative 33. And that one I can't come up with the number for because I don't know what b is. So we have that variable in there. So it just simplifies to an expression. We can't solve it. It's not an equal sign, so we stop. Here's one where we do solve because we have an equal sign, so we have to figure out what values for k make this equation true. So we're going to rearrange it. We're going to put all the k's on one side first of all. So I'm going to move the 12k over to the left side. So I subtract 12k. So minus 12k here, minus 12k here. Some of you in middle school wrote it down like this, so you know that you're on opposite sides. So we get negative 6k, and I still have the plus 7, is equal to 4. Okay, now I'm going to move the 7 out of the way, so I'm going to subtract the 7. This time I'm not going to write it down. I'm not going to put that minus 7 there. We're just going to go 4 minus 7. That gives us negative 3. And I want to, now I'm saying what times a negative 6 will give us negative 3. So my number is going to be smaller than 6. I've got to bring it down. So I would divide both sides by a negative 6. Remember the opposite of negative 6k, negative 6 times k is dividing by negative 6. So k then is the fraction 1 over 2 after you reduce it. So the 2 negative stop. Okay, that was fun, so I had to stop for a little bit for a fire drill, but here we're back at it again. So we're done with that equation. Let's see what we have next. All right, we want to take this equation and solve it for y. Now, we're not going to be able to find a number because we have an x in there also, but we just want to get the y by itself. So we are going to move the 3x over to the other side. Remember, it's a positive 3x. So when I move it to the other side, it becomes a negative. So I get 25 minus 3x. Now I want to get rid of the 5 in front of the y. So it's 5 times y. So we divide both sides by 5. That will reduce that 5 out, but we have a 5 on the other side. So my equation then is y is equal to 25 divided by 5 is 5. And 3 divided by 5 is 3/5. So minus 3/5 x. There we go. Let's take a look at this problem. We rented a car and it cost us a total of $293. The car rental was actually $180, but then they charge you an extra 25 cents for every mile over 150 miles. Well, obviously we went over 150 miles because if we'd have stayed under it, we would have just had $180. But we had quite a bit more. Okay, so if we think about this equation, remember we want to find out how many miles did you drive on your vacation, so that we're going to let that be our x, is the number of miles that we drove. So if I give you the number of miles and I ask you to tell me how much it costs, well, you're going to have to subtract, if you went over 150, you're going to have to subtract the 150 from it. So if I went 200 miles, then they're going to charge me for the additional 50 miles that I drove over the 150. Excuse me. And then we've got to take then the number of miles over 150 times 25 cents a mile, so times 0.25. And then we're going to add on the cost of $180, so like the initial charge. But altogether, we spent $293. So if we're trying to figure out how many miles we went, we've got to get the x over here all by itself. So let's get rid of the 180 first of all. So we subtract 180 from both sides. 193 minus 180 is 113. Remember, 0.25 is equivalent to a fourth, but we want to get rid of that. Now, one thing you can do is distribute, so that would be an okay option. I think I'm just going to go ahead and divide both sides by that 0.25. So I'm dividing by 0.25, which is dividing by a fourth, so I'm actually multiplying by 4. So this 113 becomes 452. If you have your calculator, you can just do 113 divided by 0.25. And now, the last step, it looks like, is to add the 150 over. So we get 602 miles is what we drove. And it cost us a total of $293. Okay, inequalities. So an inequality is a lot like an equation. We have to get the x by itself. We just have a couple of things we have to watch for. And when we multiply or divide by a negative, remember we switch the sign around. Other than that, it's just like equations. So we want to isolate the x. So we're just going to keep the x over here on the left side of our inequality. So we're going to get rid of the 6. And we move it on over to the other side by doing the opposite of subtracting 6. So we add 6. So 19 plus 6 is 25. And then we want to divide both sides by negative 5. This operation will switch that inequality sign. So it'll switch to a greater than or equal to. The negative 5's reduce that, so we're just left with an x. And 25 divided by negative 5 is negative 5. All right, so it says to graph it. So we want all numbers greater than or equal to negative 5. So at negative 5, we want to show that we are including that number. So we do a closed-in circle, and greater than is to the right. Okay, solving the next inequality, we see that this one has 2 inequalities. I don't know if you can see this yellow, but I've got 2 of these. So when I do this problem then, I want to get the x all by itself in the middle, so I've got to get rid of the 3 and the 2. So we've got to make sure and apply it to both the 5 and the 11, okay, as well as in the middle there. So first thing we're going to do is subtract 3. So all the way across. So subtract 3 from the 5. Subtract 3 from 3, it cancels out. So I have a 2x. And then even over here with the 11, we have to subtract 3. Now I want to get rid of the times 2, so I divide by 2. 2 divided by 2 is 1. 2x divided by 2 is x. And 8 divided by 2 is 4. I divide by a positive 2, so I do not have to switch the inequality signs. So we're looking at all numbers in between 1 and 4, but not including 1 and 4. So at 1 and 4, we want to put an open circle, because it's greater than 1 and less than 4, so right in here. So that's an example of a continued inequality. Okay, an absolute value equation. So remember, when we're taking the absolute value, let's say of x, and we want it to equal a number, let's say a positive 3. So if it's equal to some positive number, we know that the absolute value of positive 3 is 3, and we also know that the absolute value of a negative 3 is 3. So to get rid of the absolute value ones, then we just have to make sure that whatever expression is inside of here, we got to set it equal to both a positive and a negative. So we have 9 minus 2 inside the absolute value. So this expression then could either be a positive or a negative. So 9 minus 2x could equal 10 plus 3x, where we keep it the same. But then the 9 minus 2x. So remember that whatever inside the absolute value sign does not change, because I'm changing the other number. So this other expression, now in this case, instead of a number, it's an expression. So it could equal the opposite of that expression. So the opposite of the expression would be negative 10 minus 3x. That would give us just the opposite of 10 plus 3x. So now we solve each one of them separately, knowing that our solution can be either one of those two. This first one, let's subtract 3x. So that'll give us a negative 5x there. Negative 2x minus 3x is negative 5x. So I'm going to get rid of the 9. Now remember, we don't subtract 9 because the 9 is positive. We have to do the opposite, which is subtract 9 here. So 9 minus 9 cancels out, so negative 5x is equal to 1. And then we divide both sides by negative 5. So it's 1 over negative 5, which is just a negative 1/5. Okay? So we've got to check that. So we're going to plug it back in. So I go back to the original equation. Okay, so we're going to have to take the negative 1/5, take it times 2. So that'll give us a negative 2/5. And we want to subtract that number from 9. Okay, so 9 minus negative 2/5 is 9 2/5. And then we want to put the absolute value bars around it. And the absolute value bars make it positive, so it doesn't change it. So we want to see if it's equal to then. If I put a negative 1/5 on the other side, 3 times negative 1/5 is negative 3/5. So 10 minus 3/5 is 9 2/5. So yes, that checks. So this is indeed a solution. Our other one, let's add 3x to both sides this time. So we get 9 plus x is equal to negative 10. Now we're going to subtract the 9. Negative 10 minus 9 is negative 19. Okay, so let's check that one. So 9 minus 2 times negative 19. The absolute value of which we want to see if it's equal to 10 plus 3. Hopefully I can get this all in here, times negative 19. All right, 2 times negative 19 is a negative 38, and 9 minus negative 38 is plus 38, so we get a positive 47. And the absolute value of 47 is positive 47. Okay, on the other side, negative 9 times 3, 3 times negative 19 is a negative 57. 10 minus 57 is negative 47. And no, a positive 47 does not equal a negative 47. So that is not true. So negative 19 is an extraneous solution, so we don't use that one. We cross it out. We only have one solution to that equation, just a negative 1/5. So you always need to be watching to check on your absolute value equations. Make sure that your answers all work. Solving absolute value inequalities. Okay, so here again, it's important that you know we have absolute value, and it's an inequality. Well, for the expression to be greater than 2, that means we set up 2. This is an OR statement. So 3y plus 4, we say is greater than 2. Or we have to set up a second equation for an absolute value greater than, which says 3y plus 4 has to be less than or equal to negative 2. All right, solve both of them separately, and then we'll look at the graph to see what's going on. So subtract 4, so we get negative 2. Divide by 3. Well, it's a positive 3, so I don't change the sign. Negative 2 divided by 3 is just negative 2/3. On this other one, we'll subtract 4 also. So 3y is less than or equal to negative 6. And then we divide by positive 3, so the sign does not switch. Negative 6 divided by positive 3 is negative 2. Okay, so our solution, if we graph it, this will be negative 2, and negative 2/3 is to the right of it on the number line. So we want it greater than or equal to negative 2/3, or we want it less than or equal to negative 2. Okay, so an absolute value greater than, we set up the OR. If it's an absolute value less than, let me just show you that quickly. If it's, let's just say less than 2, then when we set it up, we go 3y plus 4 has to be in between. So less than 2 and greater than negative 2. Okay, so absolute value less than, we write it as a continued inequality. Absolute value greater than, we do 2 statements combined with an OR, because it ends up being on the outside of those critical points. Okay, well, hopefully this was a good review for you, since we have a test coming up and we really want everyone to do well on the test. All right, good job.